Welcome learners. Let us now discuss about the second powerful technique to solve any given electric circuit, and that is the mesh current method. Now, what is a mesh? So how do we define a mesh? So mesh is basically a loop which has no other loop inside. So mesh is a loop with no other loop inside of it. It is the smallest closed path For example, if I have a voltage source connected to a resistor or set of resistors in parallel, this is R1, this is R2, and I can say that this is one mesh because it's a closed path following certain nodes or certain points, and this is another mesh. I cannot, however, say that if I take this loop, then this to be a mesh. So this loop, the loop 3, is not going to be a mesh. Rather than the first two inner loops, which is a closed path, a smallest closed path, will be considered as mesh. Let me call this mesh 1, and this is mesh 2. For mesh current method, we always have to remember that it is applicable to planar circuits, and we intend to take the planar circuit because it's easy for us to do or apply various simplification techniques. For mesh current analysis, the principle of KCL holds, which means the number of currents entering is the same number of currents leaving. And if we want to find how many meshes exist inside any given electric circuit, we can derive the equations by following the principle of branches minus nodes minus 1, or you can use the essential branches with the difference of essential nodes minus 1. So this is how the mesh current method and what is a mesh go hand in hand. So when we are going to solve the mesh current problems, we are going to look at different steps to solve it. For instance, if you look at this circuit in front of you and we want to solve this, then how we are going to do analysis of it. So let us have a look at this. So the steps will be that we first need to make sure that this is a planar circuit, and we can see that there are no crossing branches. So this is a planar circuit. Next, we have to define that what meshes will be formed, and we can see that the direction of the currents basically shows that this is mesh 1, this is mesh 2, this is mesh 3, and this is mesh 4. So these are the meshes. Then we ourselves define the direction of currents. We can take it either clockwise as shown over here for all the currents, or we can take it counterclockwise, but always try to keep the same direction of current for all the meshes as shown here in the blue color: I1, I2, I3, and I4. Then once these meshes are defined, we start solving these unknown currents, go to the matrix method or Cramer's rule, and then compute the actual values of these currents. So this is how we are going to solve this. Before we begin, let us first see whether the equation provided can actually give us the correct amount of meshes or not. So let us focus on the first image A over here and see whether this equation is applicable or not. Visually, we can see that it is forming two meshes, this one and on to the right. Let us verify mathematically. So this equation says that B is the number of branches, N is the number of nodes, and you should get the value of meshes to be 2. So in this circuit, how many nodes can we have? We can have one node over here, the other over here, the third. So let me call this node A, node B, node C, and this is node D. So these are the 4 nodes. So I can write B minus N minus 1, which is, so I have 4 nodes. What about branches? So we know that total number of circuit elements equals to the total number of branches. So we have 1, 2, 3, 4, and 5. So the equation comes out to be 2. So we have 2 meshes, and we visually verified it that these are 2 meshes. What about if we use the second equation? So this is BE stands for essential branch, NE stands for essential node. And now let us see whether this equation also gives us the value of two meshes or not. So in this circuit, we have how many essential nodes? We have this B, this is one essential node, and we have this D as a ground or common point. So there are two essential nodes, which means our equation will be BE minus NE minus 1. So we know that NE is 2 minus 1. How about the essential branches? So we know essential branches are those that connects the two essential nodes. So if we move from node B to node D, there are only three paths, 1, 2 and 3. So there are three essential nodes, which comes out to be again 2. So both the meshes are mathematically verified by using any of the equations, and you can utilize any equation to solve this. In the figure shown over here on the bottom right, we basically see that how the equations are generated for the meshes IA and mesh IB. Basically, we are applying the KVL or the loop rule on these two meshes. We start from any node. Let's say we start from this point. We encounter the first voltage to be a negative. This is a voltage rise. Then we reach the resistor where the value of current IA into R1 goes. Then we follow this path and then back to this path. Similarly goes for the other path as well, and this is how we are generating two equations or mesh equations for this. Now let us look at an example and see how to solve the mesh related questions. So let us have our first question and see how to find the mesh currents. So let us take any example. Find the unknown currents. Find the unknown currents for the following circuit. So I have a voltage source, a resistor connected with another resistor, then I have same form of the circuit getting repeated, and at the end I have a voltage source. So this is a 20 volt source, this is a 4 ohm resistor, this is a 6 ohm resistor followed by 6 ohm, 8 ohm, 2 ohm, and then the initial power supply of 40 volt. And in this I need to figure out or apply the mesh current to find the unknown currents. Obviously this is one task of it. We can also find the power delivered or powered across the 8 ohm resistance. What is the powered by the sources? This is 40 and 20 volts. And how about the voltage across the 8 ohm? So these are the unknowns we can also find. So let us see how to apply this. So the idea is, first of all, we have to figure out how many meshes are. We can apply the equation of B minus N minus 1 or the essential branches. Let us do with the nodes to verify. So I have one node over here, the other is here, the third one is here, the fourth one is here, and the 5, which is the ground here. So I have 5 nodes. What about branches? So count the total number of circuit elements. You have 1, 2, 3, 4, 5, 6, 7. So you have 7 branches. So so how many it will become? 5 minus 1 is 4, 7 minus 4 is 3. So you should have 3 meshes, and visually we can also verify. So let us call this as mesh 1 with the current I1. This is mesh 2 with the current I2. This is mesh 3 with the current I3, and I am taking the direction of the current in the clockwise way. Now let us write the equations for mesh 1. So for mesh 1, we start from any point. Let us start from this point and move in the direction rightwards towards the 2 ohm and apply the KVL on this loop. So it is going to be 2 I1 then plus 8. Now this 8 is being shared by I2 and I1, so I'm going to write it as a difference of two currents, I1 minus I2. I don't need to write I2 minus I1 because currently I am in the first mesh. That's why I1 is taken dominance over here. Then I'm going to write minus 40 equals to 0. This is my first equation. What about for the second mesh? So now I'm in I2. Let's start from 6 I2 in the clockwise direction. Then I will write 6 again. 6 ohm resistor is being shared by I2 and I3. So I'm going to write I2 minus I3. I'll redraw that. Okay. This is the circuit. This is 6 ohm. This is 6 ohm. Okay. So, so it is going to be I2 minus I3 and then plus 8 I2 minus I1 equals to 0. Similarly, for the third, I can write 4 I3 then plus 20 plus 6 I3 minus I2 equal to 0. So these are the three equations which I got. I can simplify these equations for a better clarity. So this is equation 1, this is equation 2, and this is equation 3. So the three equations in a more simplified way will be 10 I1 minus 8 I2 equals to 40, then minus 8 I1 plus 20 I2 minus 6 I3 equals to 0, and then I have I1 which is 0 minus 6 I2 plus 10 I3 equals to minus 20. So these are the simplified equations, and I've written them so I can use the Cramer's rule or apply the matrix principles. So apply Cramer's rule to find the currents. So the matrix will be 10 minus 8 0 minus 8 20 minus 6 then minus 6 sorry, this will be 0 0 minus 6 10. Then you have unknown currents I1 I2 and I3 equals to 40 0 and minus 20. So you can figure out the matrix principle. Ax equals to b, x equals to a inverse b, and finally the three unknown currents come out to be I1 I2 and I3 is 5.6 amps, the second is 2 amps, and the last is 0.2 amps. So these are the unknown currents that we have figured out. Now apart from the currents, we need to find what is the power going through the 40 volt, what is the power to the 20 volts, and let us say we find the voltage around 8 ohm. So the power at 40 volts is going to be V into I, where voltage is 40 and the current IA was 5.6. But we have to keep in mind the passive sign convention. We can see that the current is leaving the positive terminal, so it is going to be a negative sign. So it comes out to be minus 224 watts. Similarly, for power at 20, it is going to be P into equals to VI, which is equal to 20 into R3. It is going to be minus 16 volts. Again, the current has entered the positive terminal, so we are taking passive sign convention to be positive. And if I want to find voltage at 8 ohm, so it is going to be I into R. But since 8 is the common branch between I2 and I1, so I'm going to write it as I1 minus I2 into R, which comes out to be 28.8 volts. So this is the voltage and the respective powers that we have figured out. We can also find the power at the 8 ohm because now we have the current. So power at 8 ohm is I square R, and we know what is I, so you can solve this. Again, the difference will be I2 minus I1, and then you apply it with R. So this is the power at the 8 ohm. So this is how you solve the unknown currents, or you figure out the unknown currents using the mesh method. Now let us see what happens if we have a dependent source. What we're going to do once we have the dependent sources with us. So let us try for the dependent sources. So mesh currents, but now we have a dependent source. How to figure the unknowns? Okay, now for this Let us take a simple circuit. This is a voltage source connected to a 5 ohm, then I have a 20 ohm, and then I have a 4 ohm, and then I have a current controlled voltage dependent source. 15I5 is the current. This is the 4 ohm resistance, 20 ohm, 5 ohm, and the main voltage source is 50 volts. And the current is moving through the 20 ohm, which is I5. And I also have another branch on the top, and this is of 1 ohm. Now, what we need to do is we need to find, let's say, the power at the 4 ohm, and by applying the mesh current method. Okay, so we can do that. We know that if you want to begin, we first need to know how many meshes. Visually we can see we will have first mesh over here, the second can be over here, and the third one is this mesh. So this is I3, let me call this I3, I2, and I1. Okay, we can mathematically justify as well if you want to how the circuit has equation of B minus N minus 1. The circuit has 1, 2, 3, 4, 5, 6 branches, minus node 1 is over here, second is over here, third is over here, and fourth is over here. So we have 4 minus 1, so it should have 3 meshes, and we already verified that visually and mathematically as well. Now let us apply the equation for the first mesh. So I can write it as 5I1 minus I3, or if I have written this as I2, so let us do this as I2. So 5I1 minus I2 plus 20 I1 minus I3 equals to 50. This is my first equation. For the second mesh, I can write 20 I3 minus I1 plus 4 I3 minus I2 equals to minus 15 I5. And for the third mesh, or okay, let's keep it the same notation. This is for mesh 3, this is for mesh 2. It comes out to be 5I2 minus I1 plus 1I2 plus 4I2 minus I3 equals to 0. Now I have these three equations and I need to find this I5. So I5 is basically across the 20 ohm resistors. So I can write it as I5 is equal to the difference of I1 minus I3. This is the current that is being shared between mesh 1 and mesh 2. Since the current direction is closest to I1, that's why we have taken I1 minus I3. You substitute this back into the equation above for mesh 3, and we should get the equation for mesh 3 to be 20 I3 minus I1 plus 4 I3 minus I2 equals to minus 15 I1 minus I3. Now for matrix or Cramer's rule, simplify the equations into a normal level or a matrix level. So the equations will be 50 equals to 25 I1 minus 5 I2 minus 20 I3. Then you have 0 equals to minus 5 I1 plus 10 I2 minus 4 I3. Then you have minus 5 I1 minus 4 I2 plus 9 I3. Finally, we solve this matrix and the currents come out to be I1 the value of So I2 comes out to be 26 amps and I3 comes out to be 28 amps, and finally I5, which is dependent upon I1, can be figured out from this, where I5 comes out to be okay. Since we can find I3 if you want, but since we are interested in power at the 4 ohm, so I leave I1 for you, use the calculator or the method. But since we are interested in the power dissipated in the 4 ohm, so we are focusing on I2 and I3. So power at 4 ohm comes out to be I square R, which is equal to I2 minus I3 square into R, which comes out to be 16 watts. So this is the power at the 4 ohm resistor and using the dependent sources. Okay, once we are done with the independent and dependent sources, let us talk about another unique concept that helps us in solving the mesh currents, and that is called the supermesh. So the concept of supermesh. So the supermesh says that whenever we have or whenever we encounter a current source, dependent or independent, or independent, between two meshes, we consider that to be a single super mesh. Obviously, using this helps us in having a simplified equation rather than having multiple equations to solve. And idea again of this course is to have simplified circuits. So for example, if I have this circuit and I want to see how many reduced equations I can get. So let us say I have this voltage source connected to a resistor, then I have this current source, this is another resistor, and then I have a voltage source. So and in between these two resistors is a common or in the third resistor. So let's say this is a 100-volt source, this is a 50-volt source, and this is a 5 amps current source. This is 6, 4, 3, 2, and 10. Once we solve this, we have to first see how we can move about this code. So let us mark the meshes in this circuit. So this is mesh number 1. Let me call this IA. This is your mesh number 2. Let me call this IB, and this is your mesh number 3. Let me call this IC. And we can also figure out mathematically. So this seems to have 4 nodes and 5 branches, and it should give us 3 meshes. And the nodes being 1, 2, 3, 4, and the total branches are 5. Okay, so if I talk about the essential branches, okay. So this is we should get these equations from the essential nodes and essential branches. Now let us figure out how can we solve this. If we apply KVL in the first mesh and see what we get. So at mesh 1, let us apply the first mesh. So we get 100 equals to 3IA minus IB plus V because there is a voltage appearing over here. I don't know the value of the current, so I'm going to write it as plus V plus 6 IA. This is my equation 1. Then I'm going to write for the second mesh, this is going to be minus 50. This is for mesh C, so let's put it as mesh 3. So I'm writing first the equations for IA and IC because I see a common current source over here. So let us see what the equation generates for us. So minus 50 equals to 4IC minus, I don't know what is the value of current voltage appearing at the current is only known, but I don't know the complete 5 amperes value. So I'm going to write plus V plus 2IC minus IB. This is equation number 2. And if I write for mesh number 2, this is going to be a simple equation of 3IB minus IA plus 10IB plus 2IB minus IC equals to 0. So these are the three equations for the three meshes. But I'm mostly interested in equation number 1 and 2 because there is a common current of 5 amperes between these two meshes. And if I try to solve this by, let's say, adding together, so the value of the V will disappear, and equation that I will get from equation 1 and 2, equation 1 and 2 should give me a simplified equation of, let's say, 50 equals to 9IA minus 5IB plus 6IC. This is what I am getting when I solve this equation. Let me call this equation A. Now, and what happens if I try to solve it further? So obviously I need to find the unknown currents, and the unknown currents are also going to be dependent on this 5 ampere because 5 amps is having a value of IA minus IC, right? This is the current difference of the 5 amps. Now if I solve this using 5 amps and put it into equation 1, 2 and 3, eventually I will get the value of IA, IB and IC, which we can solve again by using the matrix or Cramer's rules. I'll just leave the answer for you guys to attempt. So this is the currents that I'm getting, and all in fractional values, 1.75, 1.2 and 6.75 amperes. But our interest should be that what happens if we want to avoid this cancelling out of voltages from equation 1 and 2 and rather writing the two mesh equations for IA and IC. Why don't we consider it to be a single mesh? So let us see how the super mesh equation is going to be applied. So for the super mesh, let us see how we get the equation, or do we get the same equation as equation A. So whenever we have a super mesh, what we normally do is we get rid of this branch. So we are going to remove this branch in super mesh. So when we are doing the calculation, we are going to say that this branch is not here. So this is not existing, and we are going to take only this portion. So let me highlight it. Our mesh will be only this path, excluding the 5 ampere branch. This means my equation will be such now that I will write it as minus 100 plus 3 IA minus IB. Again, the original direction of the current in the clockwise will remain. I am only going to remove the branch that holds the common 5 ampere current source, and then my equation will be plus 2 IC minus IB plus 50 plus 4IC plus 6IA equals to 0. And when I solve this, I should be getting the similar equation to equation A, which is this one. So you see equation B, equation A and B are exactly similar. And what happens is that instead of going through the process of getting rid of these voltages and writing individual equation for all the meshes, we take the advantage of super mesh and come up with a single equation that will do the job for us. So this is how the super mesh equation normally works. So before we conclude this lecture, I'll leave you with one homework assignment or one problem question to practice on, so that you get a better understanding of this mesh current. So the practice problem is, let us say you have a voltage source and you have a resistor or multiple resistors, then you have another set, and then you have a current source. That's it. So you have a 16 amps of current, 5 ohm, 8 ohm, 4 ohm, 2 ohm, 3 ohm, 6 ohm, and the voltage source is of 30 volts. You need to find for this circuit the power across the 2 ohm resistor. Try to solve this